This presentation will delve into the world of configuration management, comparing the popular SaltStack tool with other prominent solutions. Well, we'll explore SaltStack unique features, its advantages and disadvantages, and how it measures up against the competition and compared to other configuration management tools. And by the end, you'll gain a comprehensive understanding of SaltStack's capabilities and its place in the configuration management landscape. My name is Jakub Kokoszka. I'm system engineer from Warsaw, Poland. And in my scope of work it's mainly telco business and telco solutions for major Polish operators, telco operators. Okay, and as you can see on my camera, I also speak to you from Wieliczka mines, and I hope that at the end of the presentation you understand the similarity of SaltStack and salt mines. Okay, so let's move to the next slide. And firstly, let's introduce the configuration management, what it is and what it gives us. So configuration management is an essential practice in IT, aiming to automate the process of setting up, configuring, and maintaining computer systems. And by automating these tasks, configuration management tools ensure consistency across various systems, minimize human errors, and improve overall operational efficiency and security. So, in short, it gives us some tools to perform some task on a large amount of machines in short amount of time. We do not need to do it on purpose, so we can automate these tasks. Okay, so we can. There are several configuration management tools available on the market. The most popular, of course, is, I would say, Ansible, and well, unfortunately, it became some industry standard. So each of these tools has its unique strengths and weaknesses. Some of the most and okay, so which tool you should select for your deployment really depends on your specific requirements, such as the size and complexity of your environment, the desired features, and the team's familiarity with different tools. But to be honest, it's not 2019 where we're in really early phase of IAC approach and configuration management. It's 2024, and most of these solutions are in various really mature phase where you can perform almost all the tasks with all these tools. So there are no any, I would say, major differences between them. And well, let's settle the SaltStack where it is in configuration management landscape. Here you can see that SaltStack allows us to not only perform some basic tasks on machines, but also manage infrastructure and install applications and, well, as I said before, perform almost all the tasks you could think of when you think about managing any systems and infrastructure. As you can see, it also allows us to manage infrastructure just as Terraform. So as you can see, well, as I said before, almost all the tools can do almost the same job, but in a little bit different approach. We'll talk about it later. But yes, you can see that it's very similar to itself. So let's introduce SaltStack. It's open source configuration management tool written in Python. So it's the first benefit of it. It boasts an event-driven architecture, prioritizing scalability and performance to handle large and complex environments efficiently. SaltStack utilizes YAML for writing state files, which define the desired configuration for systems. Additionally, it utilizes a unique pillars data system to store sensitive information, keeping it separate from state files or for enhanced security. In the next slide, I'll show you the whole architecture and shortly talk about it. The key features of SaltStack, and SaltStack offers several key features that contribute to its efficiency and user friendliness. So the main feature, I would say, is that uses event-driven architecture. So it enables SaltStack to react to changes in the environment automatically, ensuring systems remain in their desired state. What it means is that, well, when you perform any task and want to do any change on your machines, SaltStack, before it even proceeds to do it, it firstly checks if it's okay to do it. It's if all the tools are available and does not perform any changes before it's applicable, I would say. Not like I would say comparing to Ansible, because well, in us Ansible doesn't have like similar protection from changes, so you can like perform changes in some scope of your machines and not everywhere. SaltStack uses ZeroMQ messaging for secure configuration and between SaltStack master and minions. And it ensures efficiency and information exchange. As you can see on this slide, SaltStack uses server client architecture, where we have the master node where we manage our architecture, and it needs the installed agents on every machine with, and it's in SaltStack nomenclature, it's called minions. So, well, that's why I'm talking to you from the mine, Wieliczka mine. Next, we can see that it uses Pillars data system. It's a unique feature that allows you to store sensitive information, such as passwords, or in separate Pillars files, enhancing security by keeping them out of state files. It's not only the files, but it could be also stored in any other databases. It has many integrations with cloud solutions, such as well, some AWS blob storage, etc., etc. Next, we have grains, which are dynamic information about systems, such as the operating system or IP address. And SaltStack leverages this information to adapt configurations based on specific system characteristics. What it means is that you can use the same state files and YAML instructions for almost all your machines, not depending on the operating system it uses. So let's say you have some Linux Red Hat machines and some Linux Debian machines. You can use the grains to configure it, and in your YAML files you can also use Jinja templates, where you provide information what package names or configurations to use depending on your end services. And SaltStack also offers a vast library of pre-built modules for various tasks, such as package management, user creation, or service configuration. And additionally, you can create custom modules to extend SaltStack's functionality further, because it's well, it uses the plugin systems to develop it. And as I at the beginning said, SaltStack is written in Python, so it's it should be really easy to extend the functionality and develop some new features which your team need for operating. And what's the main feature also of SaltStack, I would say? It's more like state management and not operating tasks. So you can write your YAML file with desired state of your machines, which should be later applied to your machines. So it's not like the set of tasks, but desired state. And well, let's move to the comparison of the tools, so I can talk about it more, because SaltStack uses declarative approach in its basic version to deploy and perform tasks. What it means is that you, as I said before, you declare the state of the machine and your service, not the tasks which you should perform. So it's more like telling I want this and this package installed and with this configuration, not like apt install blah blah blah, etc. So as you can see here, this is the main difference between Salt and Ansible, because Ansible uses imperative approach to manage machines and services. And in comparison to Chef and Puppet, you can see it also Chef uses imperative approach and Puppet declarative approach. Next, what's cool about Salt, it uses the Python and YAML, not like Chef or Puppet, the Ruby or Puppet DSL or ERB. So it's really easy for newcomers to learn this tool. Mainly because Salt uses Python. So as you can see, for Chef or Puppet to develop some new features or modules, it could be a little bit harder because you need to know Ruby, which is not so popular language as Python, and I'd say easy, yes. The ease of setup, as you can see here, it's moderate because in comparison to Ansible, you need to not only configure the server and your master node, but you also need to configure minions. So you need to install agents on your nodes. So this is why Ansible is a little bit easier here, because you need only access those machines via SSH. But it also could be some con of this sort of Ansible, because it uses to transport the tasks and execute them. It uses SSH connection, not like Salt, which uses some message queues, and it needs acknowledgement of tasks. Yes. And what's also cool in SaltStack, it doesn't need any database to use it. Everything should be stored in files, or as I said before, in pillars. So in other secure storages. And well, as you can see, this table is not really large. I could also include here many more like features like cloud platforms, etc., and any integrations. But well, as I said also on the in the beginning of this presentation, we are in the mature state and phase of IIC solutions. So almost all the tools could perform the same tasks in a little bit approach, and well, they integrate with any cloud providers also. So it's really good, I would say. And as I read in Salt documentation, it should also integrate with almost all cloud providers, with the major, of course, like GCP or AWS. You could also use Salt to manage your Kubernetes deployments and your services. So it's also cool because it's more IIC approach, I would say. Behind almost all solutions is really strong community and ecosystem. All the tools have nice GUI, which you can deploy and well, see the tasks in a more graphical approach via web interface, your web browser. And well, what's also cool now about SaltStack, what's maybe not, let's say, um, like easy to say, is that behind SaltStack project now is VMware, because in 2020 it bought this project and it started like major development. Before it was pretty small solution. It had cool ideas, but couldn't really implement it in the world of configuration management. And now it's in its more mature phase and it's really well developed. Unfortunately, I couldn't find any objective performance and scalability benchmarks because, well, as you can think of, every provider um, like shows its own benchmarks and says that his solution is the best. But I think that nowadays every solution is good. Yes. So. Yes, but what's also worth noting is that Salt like merges the pros of Ansible and other solutions like Chef and Puppet, just like to execute the tasks via event-driven architecture, and also provides some imperative ways of managing configuration, because you do not only have to deploy your states and configure machines via states, but you can also execute remotely commands on these machines via SSH, and also in some, I would say, asynchronous way and parallel. So yes, uh, this would be end of my presentation. Unfortunately, I do not have any demo because I didn't really have time to prepare it. But well, there are plenty of videos on YouTube that can show you almost all the functionalities. And also, what's worth noting that well, before VMware acquired SaltStack, SaltStack had pretty hard learning curve, so it was not so easy to learn SaltStack. Nowadays, it has really good documentation and really good introductions. It also provides uh, some course to introduce you to SaltStack, where it shows you some basic tasks to perform and how to install and configure it to your needs and systems and deployments. Okay, so thank you all for attendance and your attention. I hope that it gave you some basic concepts of SaltStack and introduced you to this tool, how you could use it, and why it's, let's say it, a little bit better than Ansible and other solutions.